So before going into this one, let me introduce myself and then we'll start the session. My name is Amaralingeswara Kaka. So I've been in the industry last 3 decades, close to. So out of that one, I worked for IBM for 23 plus years, and then ADB for the last 3 years. And recently, we have actually started working with started uh, joining hands with Hari for the open source DB, and then we have been experimenting with the multiple solutions that are going to be part of us together, serving the PostgreSQL customers. And being an open source side, so we are actually central around the PostgreSQL as a central, and then supporting with the various specialized solutions, and then making sure that our customers gets the benefit of all these things. So that's the core intent. And then if you see here, so this session will be mostly concentrating towards the database optimization, and part of that one is actually through the parameter configuration, parameter tuning part of the things. So that's where the DBtune comes into the picture. So we are collaborating with the DBtune and then partnered with the DBtune to get the best parameter tuning and give you the best performance for maximizing the output for the whatever the resources underlying the infrastructure that you are using. So maximizing the the output for that one. So let's go into the next one. Yeah, mostly what we concentrate is like overall database performance is a vast topic. So it actually for ages or number of days or months also if we talk, there will be still will be the time left for doing that one. But today's session, what we will do is like we'll touch base what are mainly especially towards the database parameters, and then how they are going to have a serious impact on your resource utilization, and then how effectively we will manage the memory, and then how effectively we will manage the the CPU cycles to the maximum benefit, and then eventually give you the best performance for that one. So that's where actually we take that what is the importance of the introduction and then importance of the parameter tuning, and then how the Postgres actually evolved with the various number of parameters that are getting added year on year to give you the flexibility for the developer to make those ones, and then the different strategies in which strategy we can actually do those things in application of those ones, and then in that context we'll actually towards the end of that one how the DBtune actually helps, and then how much impact that can actually create for us. And that's what, and then we will have the question and answers for that one next. So we all know that okay, the in the industry the biggest part right now is there is a lot of data growth happening. It's like since morning we've been actually hearing that one there's a lot of AI and ML, all the data that actually coming. At the end, everybody ends that you are how efficiently you get your data from the RDBMSs, and then how efficiently you analyze and then give back the things. How fast you give it, that is actually going to increase the user fee. So unless you actually give that fast, you will actually not. But at the end, it needs to come from the RDBMS, and then RDBMS tuning is most important. And at the same time, since the volumes of the data is growing so fast and then so high, the biggest concern for every user or every company is how much infrastructure that we are spending. So how much of the amount of the infrastructure, and then how the cost of the things means. Let's say for example, if you look at the any of our payment gateways, right? So by the way of the UPI integrations, so the number of transactions are growing rapidly year after year, but nobody wants to pay for transaction higher price than what they have been paying previously. So even though the volumes are growing, even though the database growing, everybody's interest and intent is I get even better, even better. So how you are going to get those things better is only when you are actually optimally utilizing your resources and then get that maximum output using the same infrastructure. That's where actually our parameter tuning is going to help that one. So that's the context. So the data volumes are growing, and then the bottlenecks are like how we are actually identifying those ones, how we are monitoring those ones, and then how we are learning from the data the data workload in the current situations, and then how efficiently we actually pick those ones and then do the things. And then most of these things we'll go into details when we go into the detailed slides. But the biggest problem that what we all observe is the complexity that is growing. The complexity of the the permutations and combinations that we need to evaluate to come up with the optimal parameters is actually the very, very challenging. Further, manually, even though the gurus are tech gurus that we are actually having our DBAs, so even though however the talented they are, it's extremely difficult for them to evaluate all these combinations and then come up with this combination of parameters are the best for that particular environment on particular infrastructure. So that is the challenge. How that challenge will be done is that's where we are actually going to take the AI and ML based approach, which actually having the learning, observing, and then continuously adapting and then giving you the better parameter set. So we'll go into the details there when we go there. And and then by doing all these things, what we need to do is like in all the current rapid environment, everybody is expecting the consistent performance. So response times to be higher. So otherwise, actually, whatever the application you develop, whether it is mobile-based applications or the web-based applications, so everybody expects a faster response. If we don't get the faster response, then immediately the frustrated users gets frustrated, and then this one. The most of them actually happens is because of your database responses are poor, then automatically these problems comes. The recent examples are some of our income tax processing happened recently. So they were actually the moment you see the response times are actually reducing, the frustration actually grows up. So how you are going to reduce that one? By having the better database performance and the database response times. So we'll actually touch base on some of those ones. That's where you will actually get the faster response time and better overall experience to the customers. Yeah, if we go that like everything we are actually driven around the community Postgres, and then how we have actually been evolving, and then the powered by the whole of the global community, and then the taking this an advantage. So there are number of our contributors are actually coming up with specialized solutions that will actually help us to grow faster, to move, means like efficiently utilize the underlying database much responsive and much productive. So how we will actually do the global collaboration. So contributions from all the people we are actually taking up, and then adding more and more blocks from each of individual users, and then giving them the much more power to them. So with all these combinations, because one single area will not be sufficient, because everybody else also has to contribute from their learnings, and then they actually do that one. Like morning, one of the question that I hear in the session is, hey, the Oracle actually accepts the lot of mistakes from the developers, and then it tolerates and then gives them better error handling mechanism or better exception handling mechanism. And then it also gives you an alternatives that will actually give you the fix the problems what the customer is facing. But whereas in the Postgres side, the all of us actually expect that okay, our users are smart enough and then they don't do the mistakes. Unfortunately, that's not the truth. So that's where actually the user community help to each other and then actually make this one better and better is important. That's why we all meet together and then share our experiences, so that this will actually compete in such a way that okay, eventually the customer's dependency on the vendor locking will actually go away, and then everybody gets the vendor lock free and also take the advantage. And the real world solutions, so some of these community driven enhancements addresses the performance challenges. One of them is actually the DBtune. Growth. So if you actually see the number of parameters that are getting added to give that leverage for the developer community, so to actually see that one, it is actually going much faster. Like almost like from 200 to the 350 odd parameters that have been added over the last 3, 4, 5 years. So which is actually the number of combinations also growing, and then the complexity grows for each of the parameter to be considered that okay, what is the best value for this one in the certain workload conditions. So that actually adds a lot more complexity, and then also gives the demand. Like it is going to be even further going complex and complex. So we are forced to depend on some of the tools that manually cannot do it, and then only the way of the AI and ML based algorithms that can help us to tune much better and then things. So the optimal performance, like we all know that okay, what problems we are actually solving, and then how we need to take and what type of approaches that will actually help us to mitigate these problems. So unless we have actually the intelligence research driven outcomes that converted into products, we will not be able to cope up with the manual growth and the manual approaches that will actually solve these problems. So that's where one of the other advantage that we are talking about in the further. So, so the need for tuning. Need for tuning, all of us knows that, okay, whoever we have been in the database industry, so the database tuning is the critical part. But at the same time, however we do, so it still remains. There is some part of the things which is actually the black box, which will remain the outside. So most of the time, what we think is like our DBA will actually take care of it, or our architect will take care of it, because the performance actually linked from the way the initial days of the database design itself. What type of data types we are actually picking up, how much of the size we are actually allocating for each of our columns and in each of our data types. So it's very simple, right? Means like when you have actually the billions of rows and then a billion type, instead of giving a one byte is good enough, but you are actually adding a larger size for that one as an inter, the other sizes. Means like a billion rows into that one actually unnecessarily wastes a lot of space. The moment the space is consuming, it actually adds the problem of the performance. So similarly, the strategies from all areas actually going to contribute, and then the from the storage perspective, and then actually accessing perspective, and then these ones. So the complexity grows. So the more and more we actually contribute, and then actually do the better tuning means. So it actually covers from the database designing to the optimal query writing. The optimal query writing, like it can actually do multiple things. One is the developers write. The second one is actually the lot of tools now directs the dynamic queries, right? So sometimes they do better job, sometimes they do much more worse job. So which actually adds the complex, depends on the scenario that we are actually dealing with. So how we actually handle all of them. So is it possible to one way to look at it? Not really. So that way, some of the solutions that we are talking about actually from the database parameter side, and then that's what we go into the details. Yeah. So here, if you come across, we are coming closer to the, like the instead of concentrating all across the performance tuning of the database, we are actually coming concentrating towards the configuring the database parameters. So fine tuning the settings that match the specific workloads. So generally, as a thumb rule, what we do is like, what is the best practice that are given by the gurus. So the gurus always, what we get it is, hey, if you have the RAM of this size, so this much percentage of the thing needs to be allocated for the workman. This much of the RAM of this one for the caching is this much of the thing. So it is actually for a broader level, it works well. But actually in each of us, when we go into the specifics of our own database, our own infrastructure, this is not the truth. Because some of them are very read intensive, some of them are very very internal processing the stuff. So in each of those cases, how much we can actually avoid the IO seeking, so that much benefit we can make it. So how those are going to be counterproductive if you actually alternate these parameters, right? So how the optimal parameter configuration not having the counter productive impact on the other parameter change, that will only can come when you are able to do simulate this entire workload, and then in the synthetic fashion, and then actually run those all combinations and then come up with your numbers. So for doing that one, humanly for a DBA, it's not possible when you are actually doing the 12, 13, 14, 15 of the key parameters combinations, and then when you are actually doing the 12 factorial, which actually comes to the billions of the numbers. That billions of the combinations we will not be able to do it. Then we definitely need to take the advantage of the some of our artificial intelligence and then the machine learning algorithms, which actually can give that, oh, means like in your workload conditions with the given the machine configurations, so these are the best ones. So that's where actually these AI-based performance tuning engines actually going to help us. And then one of them is actually the DBtune. And then similarly the Fourier, like these are all standard ones. Like you can also get from the any of the blogs you read it. So achieving the peak performance. So various conditions. Yep. Yeah, broadly, if we do, like how we can actually optimize our the memory management part. So especially between the how much memories you are actually allocating for the different work mems, and then your cache, and then things, and the IO optimization. So the least amount of the data you are actually bringing from the disk side, rather actually if you are able to do within the memory. So in memory are the other aspects of the cache increasing. So all those things you can actually do it. The third one is the query optimization part. The while writing the query itself, okay, in which way you are joining the things and then accessing the data, all of them if you can actually cover it. So that is the broader classifications. We will basically concentrate in this tool, the memory management and then IO optimization related parameters to tune that one. And then query optimization will still go into the developer level. And then actually our gurus actually help them by manually evaluating the slow performing queries and all. Yeah, as we discussed, right? The shade buffers. So these are the ones actually acts as the first line of the caching for data, so that it will not actually use time to load from the database. Rather, it actually keeps in the buffer and then actually operates and then give you the best possible things. So the the proper sizing of the buffers can definitely reduce the disk IOs and then eventually increases the performance part. So similarly, the work mem. So this actually takes you that okay, how the the operations and then the creating your hash tables so that you actually access the quickly within the memory rather than actually going into the disk. The moment you added any of the disk access, the the cycles actually goes add. Similarly the cache size. So disk caching can operating system and input. So it's a combination of your operating system level parameters and then the database parameters. These two things are actually critical parts, so which will actually help you to get the faster the turnaround. Yep. Again, this is again from the purely from the database side. So how we are actually going to like, along with the access and all these things, we also need to ensure that okay, our databases are actually the the pull proof from the process perspective and then the crash proof and then are taken care by the DBtune. And then similarly, the last one is the auto vacuum. So this is another very important. Unless you have the uh, unless you have the taken care this auto vacuum very efficiently, it can be counterproductive too, because you have actually a lot of dead couples remains there, and then they will actually add the more data, the more problem. So how you are actually going to create less number of dead tuples in the system, and then also the less amount of the data that you can maintain in the system, that will automatically improve your performance. Query optimization. So it is again interlinked with the multiple of these parameters along with the really the query analysis, and then so I'm not going into the query analyzer side or the explain plan and then the analyzing those ones, because this is actually little out of the uh, syllabus for this area. But again it will actually give you that what kind of indexing actually the strategies we need to take for getting the better access to the data, faster access, and then similarly, data partitioning is another very important one. So unless you actually partitioning well, initially it will give you the same data as it grows, the volume grows on the data sizes. Unless you partitioning properly, so it will actually become a counterproductive and actually gives you the lot more delays and then the things. So you need to have the better mechanism to data partitioning side, and then if not, you can actually distribute the data into the different ranges and then properly index and all those things. So those are all will actually give you the better things. So in these circumstances, so as a developer, like our one of our developer actually picked up this DBtune and then she tried to configure on her database with the certain loads, and then she started actually experimenting with the numbers. So how this actually going to help her? How much of the time it actually reduces the manual interventions, and then also what kind of improvement that has actually come. So some of the numbers will actually come in the subsequent slides, but this will actually give you the high level picture that so what happens is like as I told, right, as a human, we have a limitation to test the combinations and then the number of iterations that we need to do it. But in this case, since this is an AI ML based algorithm that are running in the back end, it can actually, and also it can pick up the data, and then on the synthetic workload conditions, it can give you the better performance, better parameters that will actually give you the highest performance things. So so yeah, we'll go to the next slide, and then I'm actually going to cover very specific to the DBtune. So how and then which kind of parameters are as a common session in the next 10 minutes, next half an hour or something. Then I'll go into the details of the what level of parameters that we are actually giving, and then what is the amount of savings that we are going to give by the instance, and then some comparison between the AWS RDS 5.2 large machine versus the 5.4 large machine. What is the levels are actually? So I'll touch base in the next session. So I'm not going into that one. So if you see here, so since I'm rushing a little bit because you're telling that at the time. so 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 the immediate impact. So the booster, right? So because of the machine learning approach, it actually learns and then keeps the instance information and also the data workload information, and the way it actually improves the performance by tuning some of the parameters, it keeps it. And the next time when your workload changes, so which has an impact on which parameter, and then how that parameter is going to be changing. So that continuous monitoring and then observing and then recommending that okay, this parameter actually needs to be changed as because your workload is changed. So that a continuous monitoring, and then that will actually help in the machine learning approach in this one. So dynamic adoption automatically comes that okay, because you are actually good over the time, you are actually learning about this your workloads and then your machine characteristics. So you actually do it. So in case, in spite of all those things, if your TPS or the throughput requirements are not meeting, then obviously it is the time for you to move up your infrastructure. Otherwise, otherwise in general, what happens is, so the moment your current infrastructure is not meeting your throughput or the things, so immediately we go and then request for our machine is reached out of the boundaries, and then I need an IR machine. That is the standard practice, and then we've been doing that one in things because, but that's not true. When we did the multiple experimentations, we can actually do with the same infrastructure by properly tuning a double the performance than the next size of the machine. So which is actually the double the savings infrastructure, especially when you are peaking your data volumes and then the infrastructure rates. And then ease of use is, so this algorithm doesn't expect you to know anything about the AI side or the things. It can be a black box for you, and then just configure, and then it will run on its own and then give you that what parameters needs to be changed, why it needs to be changed also. You can get the explanation, so safely you can actually implement and convince your team. And then it's also highly scalable because it's not going to deal with your data volume, rather it is going to deal with your metadata, which is not actually huge. So that actually can actually do it and then implement across your instances easily and then scale. So it is not the way it is actually growing your data volume, the complexity will not be needed to grow, so you can actually easily address this. Yeah, if you see what we have observed with some of the clients that are already been taken, so which is actually the reduce the cloud infrastructure cost. So this is say for example some of these customers like Slack or some of the leading big guys. So they spend about 50 to 60%, like 40, anywhere between the 40 and 60% of their revenue just on the infrastructure spend. So you can think of that, okay, if you can actually increase your throughput, how much of their costs actually directly related to their return on investment, right? So that is the kind of customers who, like some of these payment gateways. For them also it is a pressure that okay, minimal investment and then maximum output. In all such cases, if you properly tune this database using this one, you will actually get your cloud infrastructure cost down, and then eventually it will give you the return on investment into a multi-fold. So same the fastest. The fastest is like I've heard from our gurus saying that okay, within a day actually we can actually up and running this DBtune running in any of the production environment, which is actually such a radical fast. So you can actually implement it as long as your database team actually approves and then whitelists our AWS instance that actually takes your data and analyzes, It's done. Like that, that's such easy actually. And the agent is open source agent, which does not have any proprietary stuff. You can actually go on and see that what we are doing, what we are collecting, what we are sharing. So it is actually open source. So you can actually easily trust and then actually give those permissions to us. So that way it becomes radically faster. And then most of the time what happens is like we actually deploy our DBAs to analyze this one, analyze this one. Even though it is manually impossible, but the expectations never goes away, and then we always keep on forcing them to do these things. And then, but then their time can be actually utilized where they can really have a higher impact on that one. We can actually free up their time and then put it into the much more productive issues. At the end, when you are actually consuming less CPU cycles, less storage, then obviously it actually saves your energy consumption, which actually in turn comes to the green energy contribution. And then so some of the statistics. So with the 2x large versus the 2x large machine. So before the DBtune, the CPU, it is after the DBtune. So similarly, if you look at these numbers, so your RAM usage actually reduced, your CPU usage reduced. In spite of reducing those two, you're still getting actually higher transactions per second, and then the latency, the lower latency for your response times. So which actually means which is actually doing without this DBtune. So this 2x large machine, if you are actually doing the 4x large machine, is equivalent of the performance you are getting with the DBtune on the 2x large machine itself. So which means like it is almost like 50% of your infrastructure cost can be reduced in certain workloads. So it's not that okay, every single workload will give you this much benefit, but majority of them we have been actually observing. So it can anywhere gives between the 30% to the 5 times of the benefits as well. So it's all depends on the what kind of workloads you are dealing, and then you can get the better maximum output of the CPU utilization and then the reducing memory footprint. So that's the major. Yes. Yes. So DBtune needs a open source agent needs to be installed on the database side. No, it does not need root permissions, but it still requires to access your stats. It, it needs it. No, DBtune is actually the proprietary IB-based solution that came out of a research coming from the Stanford University. As I told earlier, the Luigi is actually the doctorate from Stanford University. So a number of years of the research that they have done actually turns out to become a database automation engine. So this engine is not free, so which is actually paid, but it's a fraction of money that you are saving for your customer. So if he's saving $10,000, $1,000 spending on this tool, it doesn't actually hurt. But only thing is you need to identify the right use case that where infrastructure spend savings are actually much higher, and then it's easy to do. It's not free. Yes. Yes, I can show outside actually on both. And we can actually, if anybody requires for your specific workload or for your specific customer scenarios, we are happy to connect and then actually do a POC.
So, monitor any voice, collect any voice metrics.
We actually we observe the things, but we don't actually do any of the alert because this is not actually monitoring or alerting mechanism. It is purely for taking the input and then providing you the recommendation of the best parameters.
Use the recommendations. Will it also consider the CPU usage or IO?
Yes, yes. Well, see, ultimately, what this is actually doing is the previous slide. So your IO as less as possible will actually improve your throughput, and your CPU maximize the CPU utilization. So these are the two things. So to achieve those two common parameters, we are actually considering that 11 parameters that are coming from your wall size and then the cache and buffer. These are the things which are always related to the your data access, and then the reducing the data access, reducing the IO, and then increasing the your CPU utilization.
I'll just probably
No, no. That's why what we are supporting currently is on the any of the self-managed solutions, whether it is on the public cloud or on your on-prem. As long as it is a self-managed and you have the control, we can help. Yes, as long as it is on VM, we can support. Any other questions?